What actually happens behind the scenes when you create a virtual machine in OpenStack? It may look like one click in a dashboard, but that request travels through identity, compute, image, networking, and storage services before a working server appears. In this lesson, we will trace that journey and build a clear mental model of OpenStack architecture. Welcome to OpenStack and Linux Learning. OpenStack is an open-source platform for building and operating cloud infrastructure. It is not a single application. It is a collection of cooperating services, each focused on a specific responsibility and exposed through APIs. Keystone handles identity and authentication. Nova provides compute. Neutron provides networking. Glance manages images. Cinder provides persistent block storage. Swift provides object storage. And Horizon offers a web dashboard. Other services, including placement, help track resources and support scheduling. A useful way to understand an OpenStack cloud is to separate its major planes. The control plane manages APIs, identity, scheduling, and coordination. The compute plane supplies CPU, memory, hypervisors, and the virtual machines themselves. Storage services provide images, volumes, and objects. The network plane connects instances to one another and to external networks. These roles are logical, not a rule that every deployment must have exactly one physical node of each type. In a production environment, the roles are often distributed and replicated for scale and high availability.
The controller node is best understood as a control plane role. It receives requests, authenticates users, exposes service APIs, and coordinates work. Keystone verifies credentials, issues tokens, and supplies the identity context used by other services. Nova API accepts instance requests. Nova Scheduler evaluates available resources and works with placement to select a suitable resource provider. Glance exposes virtual machine images and their metadata. Neutron Server provides the networking API and coordinates network resources. Horizon is the web interface, while the OpenStack client and REST APIs provide automation paths. In a highly available design, these services can run across multiple controller nodes behind load balancing, with replicated databases and messaging. Compute nodes do the physical work of running instances. Nova Compute receives an instance assignment and asks the configured virtualization driver to create the guest. In many Linux deployments, that driver uses libvirt with KVM and QEMU. The hypervisor maps physical CPU and memory into virtual hardware, connects virtual disks, and attaches a virtual network interface. A cloud scales by adding more compute nodes, allowing Nova to place instances across hosts according to capacity, traits, aggregates, availability zones, and policy. OpenStack uses different storage abstractions for different jobs. Glance provides images used to boot instances, such as a Linux cloud image. Cinder provides persistent block volumes that can be attached to an instance and survive a virtual machine replacement, depending on the workflow. Swift provides object storage for large collections of objects and is optional in a deployment. The backends may use local disks, shared storage, or external storage platforms. The key distinction is simple. An image is a boot source, a volume is a block device, and an object is stored through an object interface.
Neutron creates the virtual network that an instance uses. A typical path begins at the virtual machine's virtual interface and port, continues through a tenant network and subnet, and may pass through a virtual router toward an external network. Security groups apply traffic rules at the instance interface. A floating IP can provide reachable addressing from an external network, depending on the deployment design. Neutron agents, plugins, and physical network devices implement these abstractions using technologies such as bridges, overlays, VLANs, or routed networks. Now let us follow a complete instance launch. First, the user works in Horizon, or the OpenStack command line. The client authenticates with Keystone and receives a token. The request reaches Nova API with the chosen image, flavor, network, and storage options. Nova validates the request and sends scheduling work through the control plane services. Nova Scheduler consults placement to match the requested resources with an eligible compute provider. After a host is selected, Nova Compute on that host prepares the instance. The compute service retrieves the boot image through Glance. Neutron creates or connects the required port, applies network policy, and configures the virtual interface. If the user requested persistent storage, Nova coordinates with Cinder, whose scheduler and backend create or select a volume. Finally, Nova Compute asks the hypervisor to create the guest, connect its disk and network, and start it. Status updates travel back through the APIs, and the user sees the instance become available. In production, the architecture is normally distributed. Multiple controller nodes can provide high availability for APIs and control services. Compute nodes scale horizontally. Storage can be replicated or provided by an external platform. Network services are connected to physical switches and external connectivity. The exact topology depends on the deployment tool, hardware, service choices, and availability requirements. The important idea is that OpenStack presents a unified cloud, even though many cooperating services run across many machines. Remember the four-part mental model. The control plane manages and coordinates. Compute nodes run virtual machines. Storage services provide images, volumes, and objects. Networking connects everything and applies policy. When a user creates a virtual machine, OpenStack turns one request into a coordinated workflow across identity, scheduling, compute, image, network, and storage services. If you want to learn OpenStack step by step, subscribe to OpenStack and Linux Learning. Subscribe, like, and comment.